everyone, welcome to the tutorial lecture of week 5 assignment. In the week 5 assignment we have discussed about change point detection of any extreme time series dataset, and then the second part of the assignment we have also discussed about how we can correlate with time series with the global variable, for example such as temperature, CO2 or ENSO index, like that. So, first of all we have to understand about what is exactly change point. So, suppose there is a area where we have seen observed the, let us say, rainfall extremes for last, let us say, 100 years or 60 years or 50 years, like that. And then based on that data set, when we have tried plotting that data for that rainfall extreme for different years, let us say you select the maximum value of rainfall extremes for each different years, and then you plot the data for different number of years. That will basically show that what is the total time series or time series behavior of the data set. So, sometimes it might also possible that when you are plotting that data set, it has a the mean of the data or variance of the data or some sort of the trend is present in the data set after certain time. That is clearly representation of there is a some change in the behavior of the data set in the historical time period. This change in the behavior of the data set can be attributed to as a statistical property change of the data set. More formally, from where this data set has been changed or the changed its behavior, that point or that location from that time series is called as a kind of a break point, where you can break your data into two parts and both the part of the data set might behave slightly differently. So, we can understand from the example, let us say this is one time series plot we are making it. So, this is, let us say, year information, and then you have rainfall maximum. And let us suppose this is something like this, it was varying, now suddenly it is something like this. So, if you look at here, if you take a mean of this data set, the mean of the data is somewhere here for this part, and then mean of the data set for this part would be somewhere here. And here somewhere we will have a point which is called a break point. Because this time series data set and this time series data set has slightly difference in the means. Okay. So, this is what we call the break point. It also possible that you may have the data set like this. So, initially it was very uniform, but suddenly it is increasing. So, this is also a kind of a kind of break point here, where your data set was very uniform or random fluctuation, but suddenly it is like this, and that there is a trend in the data set. Or maybe it is also possible that you may have a certain let us say R max, and then this is year, and there is an increasing trend in the data, and then suddenly it is decreasing. So, it was increasing, now suddenly it is decreasing. This is called a break point of the data set. So, this is basically called the break points, and therefore, it is very important to understand from where in the time series these break points are occurring. That sometimes gives a clue about the governing mechanism of these break points. Suppose if you plot R max and you got something since 1960 or in between or post 1960 or something like that, you are observing there is a trend in the data set which is continuously rising, which directly tell about the climate change has a significant impact on rainfall extremes in a certain region, and therefore, the behavior of the rainfall extreme has been significantly altered, has been changed, and now it is somehow it is basically increasing like that. So, this is basically one example of how the breakpoints can look like. So, this is basically the mean behavior. We can also have breakpoints something like this. Suppose this is R max and this is let us say year, and then there is a smaller variability. Now, we have larger variability in the data set. So, that is also kind of a breakpoint here, where it tells that although the mean was somewhere close, but standard deviation has been significantly changed, and therefore, initial years, let us say from here you have the data set where the standard deviation was relatively lower, but after this point the standard deviation of the data set is basically very high, and therefore, you have large variability in the data set. That is how we can get from this particular analysis like that. Okay, so more formally, if you describe in a mathematical term, a change point can be defined as, let us say you have a time series data x, where you have the data set is, let us say x1 comma x2 comma let us say xn, and then basically so this is basically your, let us say, time series data set, where it can have let us say R max, rainfall maximum, it could be your T max, it could be your T min, or it could be your Q max, etc. like that. So, this is basically different variables you can select, and this maximum value you can select from, let us say or maybe it can be not only the maximum, it can be also the mean value of year also, it is also possible. So, let us say if we are talking about there is a change in the mean, this is let us say case 1. So, here basically let us suppose this data set was following some sort of distribution function, let us say normally distributed, let us assume, and there is a this is the mean mu1, and then there is a standard deviation sigma 1 square, and then so this is the before the change point, and there is after the change point, which is let us say x d. This is normal distribution, and then you have let us say mu 2, and then let us say this is same sigma 1 square. So, basically when we are looking at this kind of the data set, we are observing that mu 1 is not equal to mu 2, and from where this is arising, that is basically considered to be as a breakpoint location. Okay. So, this is basically the case 1 which we have discussed about, where we have difference in the mean of the data set, and therefore, you have different the pattern of the time series, and therefore, you can break the time series into 2 parts, and that is also possible that you may have multiple breakpoints in a time series. So, therefore, you have one mean, another mean, another mean, and all these means are not equal, the consecutive means are not equal, and therefore, you can say that that is the breakpoint of the data set. So, for example, let us say, so this is like this, it might also possible. So, here is one mean, there is another mean, there is another mean. So, there is a one breakpoint here, one breakpoint here, and that represent your multiple breakpoint situations. The case 2 is basically we talked about where we have talking about change in the variance condition. So, change in the variance, let us say you assume the probability density functions, now you are assuming that let us say mu are same, but sigma 1 is and sigma 2 is basically changed. So, here basically this distribution is applicable where t is basically less than or equal to tau. Tau is your let us say breakpoint location, and this distribution is applicable when t is greater than tau. Okay. So, basically when this is the case, then if you compare this sigma 1 square or probably only sigma, and if it is not equal, then this is called change in the variance in the data set, and therefore, there is a change in the behavior of the your data set. That is basically called a sort of change in the variance, and therefore, that is basically where there is a tau, that is basically we confirm that that is a breakpoint in the data set, where first part of the data has a different variance and the second part of the data might be different variance. Something similarly, let us say very high variance like this, and then suddenly we have very low variance. So, that is possible. Okay, so this is basically the two cases. The third cases of the breakpoint is when we have there is a trend in the data, but the trend has been changed. For example, case 3, there is a change in trend in the data. How do we do that? Basically, how we can mathematically explain this? Let us say there is a xt means for different time period you can calculate the maximum value or the value for that particular time series where we are looking at the breakpoint analysis. So, let us say this basically this time series, the first part of the time series before the has this equation a1 t plus b1 and plus let us say epsilon 1, which is a error function, and then you have let us say tau t is less than this is condition is valid for t is less than or equal to tau, and there is another condition when we have another equation, okay, b2 plus epsilon 2 t is greater than tau. So, let us say if a1 is not equal to a2, which is a kind of a slope of line, because if you look at this equation, this is a kind of a equation of straight line. So, this is a slope term and this is your intercept. So, a1 is not equal to a2, which means the slope of the line has been changed, and therefore, we can say that there is a change in the trend, and therefore, the tau position is called the breakpoint location of the data set. Okay. It is also possible that your b1 is also not equal to b2, which means along with the slope of the line, your intercept has also been changed, and therefore, there is a maybe you can think about it. Basically, you can so if there is a only a1 change, so let us say this is your R max and this is your here information, and then there is a let us say, so this is something like this, and let us say it was something like this. It could be one slope, this another slope, or it is also possible when we have this both the conditions are true, which can be so like this and then like this. So, this is like this and this is like this. So, this is called slope plus intercept change, and therefore, there is a dual change in the property of the data set, and that is what basically we are observing from this whole analysis. So, this is basically called the breakpoint analysis. There are various methods which we can use it for doing this breakpoint analysis. For example, we can use peptide test. That is one kind of so this is a one way of we can identify the breakpoints, one method. It is widely used in R, Python, or you can also do the same analysis for MATLAB as well. The second very widely used method is called sequential Mann-Kendall test. So, this test basically gives you a single breakpoint information, and it also gives you p value, confidence interval value. So, when p value is less than, let us say 0.05, which means whatever the breakpoint this test is suggesting, it is statistically consistent or correct. Okay. When we are talking about sequential Mann-Kendall test, it has two basically time series calculation. One is progressive and one is retrograde time series, and they are looking at the when these two different time series are intersecting with each other. If it is above +2 and below -2, then those breakpoints are considered to be statistically significant one. So, these kind of the methods are available in Python, in R, in MATLAB. You can use it, and then you can enter your the time series information data set, and you can calculate where is the breakpoint. Why it is important? Because if you know the breakpoint, you will be able to understand the potential driver which are responsible for change in the pattern in your data set. Or it is also sometimes very useful when you are talking about non-stationary conditions, because one part of the data set has a different statistical properties, another part of the data set has a different statistical properties. Therefore, we should know about before applying to any kind of extreme value distribution, so that we should know about where we have breakpoints, where we have shift in the data set, and then based on that we can basically split your data set into two part, and then we can do some sort of frequency analysis or some sort of statistical analysis, and then we can compare with these types of data set. That will give us more better insight. Second part of this assignment was correlation of the extreme time series with the global variable. So, suppose you have x is a time series x1, x2, x3 and then xt. So, why it is important? Let us say you wanted to find out the potential driver of your extreme value or mean value or minimum value, like that. So, basically you can use one ENSO or global temperature, or let us say CO2, like that. So, you can basically plot in one axis the, let us say, your property. Let us say I am assuming R max. In the maybe you can write here, let us say ENSO, and then here you can write R max, and then you can correlate with the data points. So, for each year you have x1 which is R max, and for the same year you have one ENSO value, and then another year you have another ENSO value, so then another year you have another ENSO value, like that. So you can extract all these value, you can make a scatter plot and try to look at what is the relationship between your R max value with your ENSO, and then you can calculate the correlation R square. Suppose the correlation is coming out to be 0.8, which means your data has 80% variability in your R max can be explained by the variability present in the ENSO, which means there is a strong correlation between R max and ENSO. That might also possible that you have R max data, and then you have plotting some sort of, let's say, CO2 global concentration like that, and it is not giving you a good result, something like this, and R square is coming out to be 0.2 or something like that, which means there is a very poor correlation between your extreme value with your the global variables, and therefore these two things are not correlated with each other, and there is a less likely that one property is a potential driver of your R max or extreme events like that. So this is how basically we can identify, we can correlate with different processes with each other, and we can find out their correlation, and then we can confirm it whether a particular process which we are thinking about or our hypothesis is a potential input, or let's say can explain the variability in your data set and can be considered as a potential driver for your data set like that. So this is what we had, this is what we you can also further repeat this exercise, and you can understand about the basics of. You can also do a peptide test and sequential man control test in different programming language with your example data set, and then you will be able to understand how you can get the breakpoint analysis. So thank you so much for listening. This is for this particular tutorial class of week 5. Thank you so much.